Okay, so now I'm going to do page 42. Just the question, just A, D, and F. Don't want to spend too much time because I want to do another video on binomial. Okay, so in this one, it gives you a graph, and you have to use the graph to calculate the mean. So this is like we did very early on, calculating the mean from a graph. We're going to use our calculator. So what I'm going to do is I'm going to estimate the values based on this diagram they've got here. So I'm going to put in all the values across the x-axis. So it's 0 to 7. So 0, 1, 2, 3, 4, 5, 6, 7. And I'm going to look at what 0 is on my graph. So 0, I think, looks like it's at about 0.06. You just got to do your best to see what it is. So 0.2 looks like it's 0.16. 2, that was 1. 2 looks like it's at 0.275. 3 looks like it's at 0.24. I've got what I did before next to me. So 3 looks like it's at 0.24. 4 looks like it's at about 0.16 again. 5 looks like it's at 0.06. 6 looks like it's at 0.02. And this is just really tiny. 7 looks like it's at 0.005. So, in your calculator, to work out the mean, you need to go into Calc. Now, if you already set up your calculator in the other video, well done, you've been following along. If not, you need to set your calculator. The one variable frequency needs to be list 2. So you need to change this. You click list here, F2, and then you type in 2 to say you want it to be list 2, and then it's set up, and you want to do a one variable calculation, so you press F1. Oh, that's not what I got before. Done something wrong. Oh, this should be 0.06. 0.06. I missed a 0 there. There we go. Okay. So I get 2.576. Now the answer says, in the back of the book says it's 2.57. I've got 2.58 if I round it. So there is going to be a little bit of error based on your numbers. So the back of the book doesn't give you an estimate, doesn't tell you what those numbers are that you put in. But if you're close to 2.57 based on what you see, or on any other questions that you need to estimate a mean, if you're close to the value, that's fine. So I'm going to use my mean as 2.58. I don't like that it zooms out when I try and write. So I'm going to ignore this little bit of work I did before. I'm going to say that my mean, which is my lambda, is equal to 2.58. And B, you just do like we did in the last page. I'm not going to do it. I'm going to go on to D. So it says 2 separate areas, each of 1 square meter. So remember that we look at this is weta found on each square meter of cave wall. So this is 2.58 weta per meter is my average. So it says 2 separate areas, each of 1 square meter. Search for weta. Use the value of lambda that you found in B, but I actually used it in A as well. So lambda equals 2.58. Find the theoretical probability that there are no weta in both squares. Right, so no weta means I need to find the probability that x equals 0. I'm going to find it for 1 square first. So in my calculator, I'm going to go back to distribution, Poisson, and PPD, single values. less than or equal to. So x is equal to 0. My lambda was 2.58. Should move this back over here. And the result I get is 0.076. 0.075, around it, one more decimal, 0.0758. And now what I need to do to this is I need to, so there are two separate areas with that probability. So to work out both being 0, I need to do 0.758, 0.758 times 0.0758. I wrote this in my book, but obviously didn't. And then, so 0.0758 squared equals, okay, back to some standard form. So this means it is 2 zeros after my decimal point because it's -3, so it's 2 zeros, so 575. So 0.00575. My answer is slightly different to the one in the book, and this is because I have a slightly different lambda than that was used.